Hello, my name is Olga Ovtšarenko. I'm a leading lecturer at Center for Science in TTK University of Applied Science in Tallinn, Estonia. And at the same time, I'm a PhD student at the Department of Information Technologies in Vilnius, Gediminas Technical University, Vilnius, Lithuania. And this research is related to my doctoral topic, from data to action, leveraging e-learning logs for educational decision making. Article is divided into parts. First of all, abstract, in which I shortly describe this research goal. This work is related to Moodle system, Moodle platform, logs recorded data and work with this data, because my topic is to optimize learning of students, to provide any recommendation and to generate automated learning part. Because in Moodle there are pretty much different data, and I try to use these recorded logs for analysis and recommendation generation. In introduction, there is done review of related works with the same topic to the same topic. For latest work analysis and using results for next step of my research. And this study objectives are collect detailed students' interaction data from e-learning platforms, develop preprocessing methods to clean and structure data for machine learning models, and use machine learning algorithms to identify critical learner characteristics to optimize personalized. This approach do it possible to improve learning material in a course, and for students it is very helpful resource for their learning optimization. Methodology. Study was focused on evaluating and analyzing the performance of different tools in educational environment for a course data model development. And in this research, I used additional parameters, and they were created by equals, by formula. And there were two weights, credits weights and log weights. It is very simple method, but very effective, because developed model is very effective and works very good. Creation of a course data model based on historical students' activity log records. This semester, I was in internship in partner university, and I did work with pretty big course. My colleague, my supervisor of internship, provided me access to a course data, and it was very effective for him and for me too, because I have no so big course. I'm teacher, and actually my course are 3 credits or 6 credits. His course was 8 credits. Students group of 37 students learned last year this subject, construction investment and project management. And I did work with gained results. Data, first of all, was created a course taxonomy. You can see it is divided into levels. Each resource was divided into topics, by topics, into choose level. And just now it is shown like Bloom taxonomy. And you can see relation between resources and between levels. My colleague helped me to discuss this structure, and it was a very useful discussion because for my colleague it was another view at this course. It was very helpful for him and for me too. Data collection. I started from data set which consists of 78,000 rows of different data. After cleaning, this set became to 38,000 records. And in addition, I counted aggregated parameters, weighted parameters. It did possible to develop a very good data model, and its training was very effective. And here you can see coding, because data from model needs coding, not only cleaning. It is needed for machine learning algorithm use. And after, you can see here are formulas for additional parameters gaining. And on Figshare platform, there are provided information about algorithms and about counted data. And now you can see correlation matrix. Aggregated parameters are in very good relation to each other. And in different colors. Blue color means that it is inverted relation, but it is very high too. Machine learning algorithms was used to check reliability and efficiency of obtained data. And you can see Pearson correlation is very high. In addition, I checked the data model just work with additional parameters, Spearman correlation, and it is ideal one. And that means that the course developed model works correctly. But later I improved this model and I got the better results. But unfortunately, they are not described in this article. And like result, I composed this table in which you can see which part from a model platform is suitable for automation and which part is not suitable for automation. For example, students' feedback in free text is very difficult to automate. And for discussion, I offered two possibilities for teachers and for students. For students, it is possible to predict their dropout. It is possible to optimize their learning part and to generate any recommendation. And this process can be automated. And for teachers, it is very useful method for their course improving because teachers can see which resources are used or not used. And in this way, they can improve their course. And conclusion. Student activity with weighted parameters method was used for aggregating additional parameters and for development of the data model. And it was used for analyzing learning outcomes and for development strategy to prevent students dropout and for improving their learning results. Validation of the data model with aggregated parameters showed its performance for predictive analytics, and using this data model in machine learning algorithms in combination with obtained historical data of student results can be used to predict learning outcomes. Method which was used is very useful for course developers to clarify and improve a structure of a course, to understand any effectiveness or ineffectiveness learning tools, and using this strategy and techniques is very useful for designers of a course for analysis and not only development but for improvement of done work. Adaptation of learning environment with machine learning methods is very powerful method, and I'm using this method, and I hope that it would be finished this year, and it would be finished with plugin development for Moodle platform. And here is presented reference of the article, and this part is with repository with data set and algorithms code. Thank you.